We are filming. Let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Sanctum Michael Arcangelo, defenda nos in premio, contra nequitia et insidias diaboli, est presidium. Impere illi Deus, supplices te precamo, tuque princes militiae celestis, Satanam, aliosque spiritus malignos, qui ad perditionem animarum pervegantur in mundo, divina virtute in infernum deterrere. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. All right. Have seats. Take out your notes, please. I want to finish off the notes that actually will empower you to do the worksheet I'm going to give you. There are notes out. Feet head up. Notes out. Doesn't look like folded arms. Thank you. There are two special trig limits that you will need to memorize. How many people caught what I just said? Yes, that I have to say. You have to memorize. I'll memorize them as soon as humanly possible. A, they'll be on the worksheet for tonight. B, they'll be on the test. So, the first one, the limit as x approaches 0 of sine of x over x out of curiosity, how many people have the graphing calculators? How many people have them with them? Take them out. We're going to do a little bit of practice today. Later on this week, I'm going to give you a full-fledged crash course in how to use that. There are lots of interesting functions on there. Later on in the quarter, if anybody's interested, I can actually teach you a little bit of how to program the thing too. It does have a built-in computer which can run programs, some of which can be very useful. Like you could get the quadratic formula to run in one step. If you know how to program it, I can show you that later. But for now, there are actually two versions of number 2. I'll explain why there are two versions in a moment. These number 2, they both have the same answer. I'm going to step you through a little bit today. One of the key things you'll need to know how to use on your calculator is how to graph things. So if you'd be so kind, grab your graphing calculator. Hopefully you found the on button. And hopefully you found the button that says clear, which is on the upper right hand corner. If you hit on and you hit clear, if you hit clear enough times, you should have just a blank screen. Okay. Is that clear? Okay. Now, I didn't even know there was one until that came out of my mouth. So, on the upper left-hand corner, you should see a button that says y equals. That's going to be one of your best friends. Hit the y equals screen. Hit the y equals button. You should, when you hit that, see a string of y1 equals, y2 equals, y3 equals, and so on. Somebody see that? Okay. Does anybody have anything in those entries? If you do, that means either you or somebody else were playing with the screen. If it's completely blank, that's actually good for our purposes. Does anybody have any junk in that screen?
I did, but
You cleared it out? Good. I was just going to step to people on how to clear it out. Go up to the Y1 row. Yeah.
Sorry, should we be in plot 1 or?
Oh, just hit the Y equals screen. Plain old. Yes,
Yeah,
there you go.
But like plot 1.
Oh, plot 1. I can. Oh, good. Thank you. Does anybody does everybody see plot 1, plot 2, plot 3 on top? Are any of those dark for anybody? Okay, I'll do that. Basically, you can take the arrow and go That's a
Do
statistics
we want
thing.
a plot on?
We do not want plot one on. I was just turning it off in case it was on. So everything should be clear, and you should have y1 equals blinky blinky cursor. That's the word. Here's what I'd like you to type in. X, how do you type X? There is a special key set aside specifically for X, although it's a little hidden. The key on the calculator says X, comma, T, comma, you might recognize theta, which is like a 0 with a belt, comma, N. That's the variable key. If you hit it, you'll normally get an X. You can also use the alphabet key, the alpha, which
Okay,
is
so we
usually
use
green or
either
something.
one?
Those are, either one is fine. It'll give you the exact
Yes,
same letter.
it's on
You could do alpha STO. Will get you the X as well. It's a little faster to do the variable key. The disadvantage is if you want a variable other than X, you'll have to do the alpha. So, everybody got X? Can everybody see the X squared key? Should be on the left-hand side somewhere. Go ahead and hit it. All it should do is add a square. It doesn't add another X, it just squares.
Do we want X squared?
Just X squared, correct. Does everybody have that? Now, what I'd like you to do is go to a button really near the top called Zoom, Z-O-O-M. There are a couple options. There's Z-Box, Zoom in, Zoom out. If you have the fancy schmancy calculators, you might have a few extra choices. I want to go down to where it says Z Standard. I think for most calculators it's choice 6. If you have a CalActors, it might be choice 7. Once you get down to choice 6, use the arrow key to go down to choice 6, hit enter, and then watch the screen. What do you get? Should get a parabola of y equals x squared. Go ahead back to the y and equals screen. You should have the x squared. Anybody not have it worked?
Doesn't work.
How do you go back?
Oh, just go hit the button, hit the y equals button.
Oh, okay.
Does everybody have x squared still there? I want to play with this. Hit clear. I want you to type this instead. Now this is going to take a little bit of exploring. This is not a subtract sign. It's the negative sign. You will not find it above plus. You will find it below and to the left of plus. It should be this key. It's right next to enter. If you type in the wrong thing, the calculator will yell at you. It'll say syntax error, which basically means you typed something incorrectly.
You want us to go down to standard again when we're done?
We'll do this in a moment. So negative, then type 2. You will need to manually type the parentheses. So negative 2, left parentheses, it should be right above 8. It's an actual key. Then type in x minus 3. Then I do want subtraction. This is an actual subtraction. So if you do x negative 3, it won't work. X minus 3, close parentheses, hit the square, and do plus 5. And then as soon as you're ready, I'm going to show you a little shortcut. The zoom setting was to make sure everybody was in the right, because zoom will either zoom your graph in or zoom your graph out. Now that everybody's on Zoom Standard, you can just hit the graph key on the upper right hand corner. Go ahead and do it. Everybody see it? Should have an upside down parabola with a vertex at 3, 5. And the height multiplier should be 2. Over 1, down 2. Over 2, down 8. Etc. It's a little hard to tell because the dashes
How
are
do
so
you
small.
know that it's 3, 5? You can just look at it and count?
Kinda, sorta. Do me a favor. Does everybody have this on their screen? Gentleman on the back? Everybody have this on the screen? Right next to graph, what do you see? What button? Trace. Hit that. Now, depending on where your calculator is, you might get different answers here. Hit the trace button. Do you notice what just appeared on the top of the screen? Y1 equals. It gives you the formula for that. What happened to, what appeared on the bottom? Yeah, you got x equals something, y equals something. Usually it'll start at x equals 0. Hit the right arrow a couple of times. Watch what happens. Describe what's happening.
It's like puts a point on the parabola.
Yeah, do you see that little it's like a little spider thing that crawls along your graph. Hit the left arrow a few times. You can go back. This gives you values along the parabola. Now the decimals are usually pretty horrible. And if you ever lose the screen, just hit trace again. What if you want an exact answer there? Because I'm getting like 0.8510638 bubble, which is horrible. Physically go to the number keypad and type the number 3. What happens? What's on the bottom? X equals 3. Hit enter. It will sort of hyperwarp to the number you want. What does it say? 3 comma what? 5. That's the vertex. That's one way to check. Is everybody clear? So that's just a quick 3-minute crash course in A, how to enter equations, that's the y equals screen. B, if your graph is goofed up, how to go to zoom standard. And C, how to hit the graph key. And then, well, and D, how to hit the trace so that you can get individual numbers. It actually goes way far off screen. If you type a number off screen, it'll yell at you.
Keep on going.
You
How far
can.
does it go?
Oh, are you hitting the arrows?
To like
It'll keep scrolling forever.
I'm at -400.
Yeah. If you try that trace and then type a number,
Where are you at?
you have to stay on screen. If you type 100, it'll say error invalid because it's off screen. Okay? Questions?
At -1,000.
All right. Can everybody find the quit function on here? QUIT, quit. Where is it? Second mode. Second mode. That's probably the third most important thing to know on the calculator. Quit. That will get, if you're buried in a bunch of menus, hitting quit will probably get you out. If there's a program running, quit often breaks the program and stops. So it's very handy. And then the last but not least, turn it off. You won't need it for now. We will bring this back again in about 10 minutes. So keep it handy. But for right now, the limit as x approaches 0 of sine of x over x. Can I plug it in? I'm going to go through my list of limit finding things. No, blows up. Can I factor? No, sine of x is not a factor as far as we know. Is there a common denominator I can find? No. How about getting a radical out of the top? No, there's no radical. Squeeze theorem, we don't even know what it is. Haven't covered that yet. Graph it. Okay, it was 2 minutes instead of 10 minutes. Grab your calculators again. I do need you. Go to the y equals screen and clear out everything. And then I'd like you to hit, you know where the mode key is? You hit it in order to do quit. Hit the mode key right away. There's a whole bunch of calculator settings.
Wait,
Mode is right next, up near the top left. What's that? It doesn't matter where you hit it. When you hit mode, it forgets what it's doing and immediately says, oh, you want to change my settings. I would like you to look for the third row down or fourth row down, depending on your calculator. One of the words says radian, one of the words says degree. Remember those from last year when you were graphing sine, cosine? I would like it in radian mode. Radian mode. For the vast, vast majority of this class, we're going to keep it in radian mode. We're going to do everything in radians.
So you just hit enter?
Correct. And make sure that the word radian is darkened. Then the graph should work. Is everybody good? Everybody in radian mode? Go to the y equals screen and type this in. Sine of x over x. If you're on an old calculator like mine, it should look like this. y1 equals sine parentheses x, close the parentheses, divided by x. Go ahead and do that. Sine x. Don't forget to close the parentheses before you divide by x. Sine of x over x. Everybody set? As soon as you're ready, hit graph. You should have a very, very short looking graph. Should have a very, very short graph. If the graph is messed up, or if you're way off to the side, go to zoom and select zoom standard. That'll always get back to normal. If your graph is off screen or in any way messed up, go to Zoom and select Zoom Standard. Does everybody have a graph that's relatively short
No, I am.
that looks kind of sort of like this? Okay. I'm about to show you how to get a closer look at this, because I can't really see it very well. Go to Zoom. Go down to where it says Zoom In. Hit the Enter key once. It should just bring you back to your graph and not change anything. On the bottom, what does it say? X equals what? 0 and 0? Good. That is, hit the up key a couple of times. And then hit the right key a little bit. You see this teeny weeny little crosshairs that's moving around? You get to choose where to zoom in from. Now I'd like you to go back to 0, 0, but you can zoom in from pretty much anywhere. But go back to 0, 0, and as soon as you're ready to zoom in, hit Enter. The graph will change. You're going to get a blown up version of this. You should have something that looks a lot like this now. If you don't, go back and zoom standard, then zoom in. Clear on that? Zoom in. Well, go back to zoom and select zoom in. Hello. And then make sure it's at 0, 0. Hit enter. Now, if you hit enter multiple times, it'll zoom in multiple times, and you'll probably lose the picture. Because if you zoom in too far, you'll just see a blank space because you're just looking at this teeny little spot here. Okay, so if that happens, just go back to zoom standard and then zoom in again once. Clear? Here's my question. We've got a graph. It looks like this. Can somebody answer this question for me? Maybe look up here. Maybe look where I'm pointing. Can somebody answer this question for me now? What? Yeah, it's 1. Use x equals 0. As x gets closer and closer to 0, both of these sides seem to be approaching a height of 1. And as a matter of fact, that's true. Yeah.
I think I broke my calculator.
Let me see. Oh, you can go back to zoom. Oh, I see. Oh, you see these little flicker things?
Yeah,
If you hit enter, it was paused.
Oh.
Yeah, that happens. I didn't expect that to happen. That's funny. If you're graphing, it usually takes like 3 seconds to graph. If you accidentally hit enter while you're graphing, it pauses the graph and just waits. And there's a little flickery thing in the upper right-hand corner. So if that ever happens and you say, my graph just froze, then usually hit enter, try again, and it probably will unfreeze. Thank you for pointing that out. I will say this. Anyone remember the types of discontinuities from last year? The things that can blow up a graph or interrupt a graph? There's a fairly spectacular thing that can interrupt a graph, like what? We've been playing with all of that. What's that? Yeah, that causes a what? On a graph. It could actually cause 2 possible things.
Flip?
That's when you multiply by -1. But if you're dividing by 0, what object, like over here, what sort of object is it x equals 0? It looks like. Maybe. What else could happen? What? An asymptote. So if you divide by 0, you could get a vertical asymptote, or you could get a hole, depending on if it cancels or not. Does this look like a vertical asymptote is here? No, it would have swooped straight up and gone to infinity or down. Guess what's here? It's a hole. Now you might say, well, what? Hey, you can just cancel the x's. No, you cannot cancel the x's. This is not sine times x. It's sine of x. But I won't be able to tell you the explanation of that until 3rd quarter. So I'm going to keep you in suspense for a long time. But for right now, just take it on faith. There's a hole there. As a matter of fact, I'll prove it to you. If you can follow directions carefully in the next 3 minutes, and then follow directions carefully for undoing this, I'm gonna totally mess up your graph, and then I'll tell you how to unmess up your graph, okay? Go to zoom, and select Z decimal. That's one of the preset zooms. It's a little bit less than the normal zoom in, but it's decent. It'll give you a good shot of it. Now watch this. You see the x-axis and y-axis on the screen? This calculator has the ability to turn those off. Right above zoom, if you do the second function zoom, do you see the word that says format? Go there. Format. Do you see a choice that says axes on, axes off? Now use this at your own risk. Go over to axes off and darken it. Hit enter. That will turn off the x and y axis. They'll be invisible. Axes off. Oh, you have colors. That's right. You'll have to go into it and select none, or select white. White works, or off. Either one works.
There is a hole.
Hit graph. What do you see? You see a teeny little gap at the top? Welcome to your hole. Questions? Now, please go back to formats. Does everybody get a good view of that? Did anybody not see it yet on your calculator? I wanted you to see with your own eyes the hole that was on the graph. If you have not, continue on until you get it. Everybody good? Go back to format, which is second zoom. Turn your axes back on, or turn it back to black, or whatever your graphic is.
How do you do that?
Format, so second zoom. And if you have a colored calculator, you'll have to go to the drop-down menu and select the color, which is black, I think. Now graph again. The axes should be back on. Having the axes on is very, very useful in this class. So if they're off, tell me. Don't just sit and suffer saying, I don't know where I am because I don't see any dashes. That's because the axes are turned off. Everybody clear? So the answer to this is 1. I would like you to memorize that. The limit as x approaches 0 of sine of x over x is equal to 1. Memorize that. You will need it. The second one, the limit as x approaches 0 of 1 minus cosine of x over x, seems to have the same problem. It's going to divide by 0. Nothing cancels, no radicals, no common denominators. We're stuck. If you graphed it, you can try graphing it if you want. Actually, why not? Life's short. Type in, the only catch is, look up here, you will have to have parentheses around the 1 minus cosine of x. On your calculator, you'll have to have little parentheses around the x as well. Otherwise, it just divides the cosine by x. Clear? So parentheses, 1 minus cosine x, divided by x. So parentheses are on the top, otherwise you'll get the wrong answer and the wrong graph. Go ahead and hit graph. You should have a sketch that looks a lot like this. And I will spoil the ending for you. There's a hole at 0, 0. Because I did it earlier. How would we know it?
Yeah.
We would go through with the zoom standard and turn off the axes and see that.
Wasn't it zoom decimal?
I just skipped over that.
Sometimes, if you do that, will there sometimes not be a hole?
If you see a gap there, then there's a hole.
But sometimes
If
there
you're on the
isn't.
wrong zoom setting, it might be too far out to see the hole, because it might be too small.
Is there always a hole then?
In this particular formula,
No, just in general.
no.
Okay.
It would go straight through. Like this looks a lot like sine of x. There's a plain old regular dot there. Yeah.
It says y equals 9, 7.
That is exactly, yes. That's another indicator that it doesn't exist.
Why is this, is that normal?
That's fine. It's zoomed out a little bit. That's the right graph. Okay, gentlemen, tune in. Did everybody see the graph? Does it look something like this? You'll probably won't see the hole when the axes are turned on. What's the answer? What's the calculus answer here? It's 0. From both sides, it agrees that the height is aiming towards 0. And that's going to be true for both of these. The reason it works for both, Max, trick question. What's 10 minus 3? What's 7? What's 3 minus 10? Negative 7. What happens when you take a subtraction and flip it to the answer? Like x minus y, and then you flip it to y minus x. What does that do to the answer? It makes it negative. It switches the sign. Do you see why these would both be equal to 0? This is 0 and this is negative 0, which is 0. Make sense? I'd like you to memorize either one or both of these versions. I usually find the top one easier to memorize. I have no idea why. Depends on how your brain works. Both of these are identical as far as our purposes go. Those are the two limits I'd like you to memorize. Now, let me show you a variation on that. There's a rule which says that you can do anything you want. Yeah, question.
For the second
This one?
formula, do we have to put parentheses in when we?
If you type into a calculator, yes. And you'd have to have a little parentheses around the X. The calculator will probably do that for you. But yeah, you need to put parentheses around the entire numerator. All calculus operations can factor out a GCF all the way in front. I'm going to need to explain that.
Wait, so this is a rule all the time, or is this like
Correct.
for this example?
This is true for calculus on up through whatever level of math you ever get to go. All calculus operations can factor GCF all the way in front. Now it has to be an actual GCF. Quick example. The limit as x approaches 3 of 5 times f of x. Go ahead and write that down. I did this totally random. Is equal to 5 times the limit as x approaches 3 of f of x. In other words, you could pull the 5 up front. That's always legal. If there is a number multiplied to your function, you can pull it out even in front of the limit. And that will actually make your limit easier to calculate. It'll be 5 times smaller. Okay. What if I did this? Let me erase this one. This is a little tricky to see, but once you see it, you'll probably have it forever. The limit as x approaches 0 of 7 sin of x over x. I'm curious what the answer is. The normal way to do this would be to graph 7 sin of x over x, and then see what happens as the graph approaches 0. Does anybody see a trick to this?
Well, if sine of x over x is 1, then you just multiply it by 7.
Well, what can you do with the 7? There's a way to prove. First of all, you're right.
You
You
can,
can-
so it's 7
Exactly.
Limit.
It's really 7 times this. Did I promise you that any number times sine of x over anything was equal to 1? No, we cannot assume anything. In other words, this is kind of like scary unknown. We've completely raw memorized it. It's like taking a picture of it and just holding it with you. You know, frame it, put it on your wall. It's like, this is all I know. If you change anything in here, I no longer know what the answer is. Why? Because I haven't the foggiest idea how this works. I mean, I do, because I've been through the class, but we do not know how this thing works. Like, why? Does this thing cancel? Does it do what? We don't know. All we've done is memorize. So if I change anything, if this is sine of y over x, game over. 2 sine of x over x, game over. Sine of 2x over x, game over. If you change anything, x approaches 3, game over. If you change even one teeny thing in here, the answer is no longer 1, as far as we know, except by accident. Clear on that? So in other words, how do we know this answer? We memorized it, and that's it. There's no secret knowledge here yet. Later on, we'll actually explore why this works, but that's the third quarter. For now, memorize it. In other words, see this up here? Everybody looking up here? They changed something. I cannot assume that it's 7. I cannot assume it's 7 times 1. If I get this back, I know this is equal to 1, and that's all I know. Does everybody see that this is something this is not something we can solve, but this is something we can. Why? Because this is exactly what we memorized. This is not. I haven't the foggiest idea what this is. I do know what this is, because this is a problem we memorized. This is 7 times 1, which is 7. Make sense? Yeah.
So, we're like multiplying the limit with everything else?
Yeah, in other words, the rule is if you have something multiplied in front of the inside limit, you can always pull it out in front.
Okay, so like on a calculator, could I put like, is there a button for limit?
Not exactly. Yeah. Short answer is yes and no. And it kind of depends on what version of the calculator you have to. For our purposes, the answer is no. We're going to be doing limits by hand, but the calculator can help us if absolutely necessary. Now try this. This is a little harder to see. The limit as x approaches 0 of sine of x over 5x. Okay, math smarty pantses. Is this something we know the answer to? No. No clue what the answer is. How come? Because there are only two formulas we've ever memorized that are special. X approaches 0 sine of x over x, that's the only one. Or x approaches 0, 1 minus cosine of x over x. Those are the only ones we know. This is not one of those. Can anybody see a trick by which you can transform it into something we do know? Yeah.
Well, did you see it with 1/5?
Very sneaky. What number is in front here? Technically? 1. This is a GCF. It's a constant in front, which means you can pull it out in front. 1/5 times the limit as x approaches 0, sine of x over x. That is something we know. So 1/5 times 1, which is 1/5. Make sense? That's the only way we can solve this problem. Like, let me give you a quick, silly example. Is everybody okay on this first one? We got this. This is actually kind of similar to a math. There's a math competition that they sent some of us to in high school, and I kind of crashed and burned, but I kind of memorized all the things I messed up on. There. This is actually, I'm really dating myself. In the late 70s, they had a program, the health department had a program where they're trying to educate little kids of why do you not go into the cabinets and drink bleach, because it, you know, it looks fun and it's these multicolored bottles and oh boy, glug. You don't do that. They made, this was called Mr. Yuck. It was a cartoon character. They put brightly colored stickers with red or putrid green with a Mr. Yuck sticker, and you put them on things that are poisonous. So the mom and dad would take a Mr. Yuck sticker and put it on the bleach, and then put it on the household cleanser, and so on. You know, that's Mr. Yuck. Mr. Yuck equals 7. That's on it. Now, if I say you can tell me what that equals. No clue. I did not tell you how Mr. Yuck came to be equal to 7. All I know is it's a mystery, but we just memorized it. What about this? I should do this. Sorry. Edit my eyes. What's that equal to? 21. How'd you do that? Yeah, we knew that Mr. Yuck was equal to 7, therefore 3 times 7 is 21. That's what's going on over here. All we know is that sine of x over x, as the limit goes to 0, is equal to 1. We know nothing else. Just memorize it and take it on raw faith. That's why I cannot calculate this straight away. Unless I can get these numbers out, the problem is dead. But since it's a number multiplied in front, you can pull it all the way in front like a GCF, and we're good to go. Does that make sense? Take out, oh yeah, I haven't given it to you yet. You can't take it out. The next worksheet. There are a few special limits here. On a lot of these, I'm actually going to encourage you to use your calculator. You can use them, well, some of them they won't be much help. Some of them, it's way easier to do it by hand. But for example, I will caution, number 1, x approaches pi over 2 from the right of negative secant of x. Does anybody remember what secant is?
Opposite of cosine.
Not opposite, but it's the reciprocal of cosine. It's 1 over negative cosine of x. That's what you can type into the calculator. Now, beware. It might be just as easy to do it by hand. If anybody remembers how to graph secant and cosecant, they look like those U shapes. Like there's a U on the top, U on the bottom, U on the top, U on the bottom. It's sort of like blow up the bases and then, remember that? I'll take that later. But for now, type it into a calculator. Graph it, and then see which way the graph is going. I'll tell you right now, number 1, basically if you want to graph y equals negative secant of x, it looks like this. Does anyone remember cosine? How do you graph cosine? Where does it start, where does it go? Where does cosine go? Okay.
Starts at the origin, right?
Actually, sine starts at the origin.
Oh, and it starts at the max.
Yeah, it starts at the max, and then goes down. Min, base, max. This is cosine. Gentlemen, tuning in. If you missed this, you're going to be kind of lost. This is from last year. We did go through this briefly. This is the graph of y equals cosine of x. Clear? Now, you notice it's negative? How do you make negative cosine? Where do you start? Where do you go? Michael? Yeah, start at -1 and go where? base, max, base, min, base, max, base, min. So here's negative cosine. How do you do negative secant? There's a trick. I don't know if you remember this from last year. You see these are base points, points at the baseline. Blow them up. Go blow up the bases. It's kind of a military term. Put a vertical asymptote every single time you had a base point. If none of this is ringing a bell, I'll give you a crash course on how to graph the reciprocal trig functions later in the week. But for right now, the max goes to the max, the min goes to the min. Paula, chase the asymptotes. And if you remember, you're counting by pi over 2s. Pi, 3 pi over 2, 2 pi. So look at the graph. There's the graph of negative secant of x. What's happening as x approaches pi over 2 from the right? It's going up to positive infinity. Here it is. That's the answer for number 1. The answer is positive infinity. Okay. On your graph, if you graphed it correctly on your calculator, you might have to play with the zoom settings to see it properly. You would see that as x approaches pi over 2 from the right, it does go up forever. Clear? Number 2 is normal. Number 3, graph it.
This is like the heartbeat of a person who's dying.
Caution. Look at number 7. Notice anything? Yeah. First of all, there's an absolute value. What's up with that? What's the absolute value of negative x? It's x. Correct. Now,
So do you want us to graph it?
I would. I'd like you to type it in. Oh, and I got to show you one last thing.
So what you can-
On your calculator, there is a way to find absolute value. What time is it? Oh, come on. This happens in calculus a lot, by the way.
You still have 5 minutes.
Yeah, I know. Tell you what I'd like you to do on this is start it. It's not going to be due tomorrow. It will be due on Wednesday.
Today's Wednesday.
Oh yeah, what am I saying? It will be due on Friday. Wow. It's been a week. So, it's like, yeah.
So you want us to graph it on the paper?
You can, or you can graph it on a calculator, whichever you like. Just be careful. Graphing it on a calculator can be challenging, especially getting the right zoom settings and knowing what you're counting by. Good question. Oh.
Well, I guess I'm just trying to figure out my calculator and plugging it in and I'm getting a really funky graph.
Oh, that actually is accurate.
Oh.
It doesn't know how to lift its pen when it draws the arcs. There's a way to fix that. I'll show you next week.
I see.
Yeah, just pretend those smears in between are not. Yeah.
One's like number 2 where it's just as x approaches negative 2 from the left.
Anytime you have a one-sided limit, probably want to graph.
Can we just do it on the calculator?
Yes.
That's so much faster.
Can we do,
Yes.
can we do number 2 on the board?
We could.
Just 'cause I
Although, on number 2, if you're graphing it on a calculator, put parentheses around the bottom. 1 over parentheses x plus 2.
So that's
If you
all.
don't have parentheses, it'll be wrong.
Oh, really?
There should be a vertical asymptote at x equals negative 2. And it's a single asymptote, which means one side swoops up and the other side swoops down. The graph should tell you pretty immediately which side swoops up and which side swoops down. I'll tell you right now, the answer to this is either going to be infinity or negative infinity. You have to tell me which.
So is this right?
That is correct.
Okay.
So what happens is you approach from the left.
Oh, okay, got it.
Correct, that's the answer. Everybody okay? Getting close to the end, but I want to talk through number 7. Absolute value, please write this down in your notes, which means you have to have notes out. How do you get absolute value if you want to graph it? On your calculator, there is a menu called the math menu. Anybody find it? It's an actual key. Look on the left-hand side.
The third key.
Third key down usually. Go ahead and hit the math menu. It has loads and loads of smaller menus in it. Scoot over to NUM. Which is short for numbers.
It says abs.
It should be choice 1, ABS. And that'll take the absolute value of x. So if you want to take graph the absolute value of x, type an x in there. Now you'll have to go to the y equals screen, then grab this ABS. Actually, let's try that once.
What does ABS mean?
Absolute value.
Oh.
Absolute value. It does not mean, yes.
No, I was thinking
Okay.
ABS like in your car.
Oh, that's anti-lock brake system.
Yeah, but it's
But
like
no, it's not that. One last thing, go to the y equals screen, just so everybody knows how to do this, hit clear. Is everybody on the y equals screen? Y1, blink, blink, blink.
Wait.
Go to the y equals screen. Oh, you got it? Okay.
Okay.
Go to the y equals screen, make sure everything is cleared off. Now, don't hit anything except math. Now scoot over to NUM, as NUM. Select ABS. Does it say Y1 equals ABS, blink, blink, blink?
I have the 2 bars.
Oh, you got absolute value bars. That's even better. If you got the fancy schmancy one, it'll give you the bars. Type X. And if you need to, do another parentheses. Hit graph.
Wait, parentheses in the X?
On the other side of no, you don't need parentheses. Just the people with the old-fashioned calculators that needed to get the other parentheses. It should look like a V.
Wait, just X?
Yep, just X inside it. And then do the other parentheses if you need to. And now hit graph. That's it. If you've got a V, congratulations, you've graphed the absolute value. Tomorrow and the next day, we're going to do some more exotic things like the absolute value of sine of x and things like that. Yeah.
Is there any way, I don't know why it's like usually in the smearing, is there any way to fix the?
There kind of is. It's a little bit of a longer story, but
Okay.
ask me tomorrow and I'll show you. It's tricky. I can show you tomorrow because there were a couple other people who have the same problem.
Okay.
All right, that is all we have time for. Please rise. People watching at home, enjoy. Have fun, be happy. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and of the Holy Spirit. I should have been showing the graphic calculator to the camera. I'm sorry. We'll do that tomorrow. Or you can just come back. That'd be awesome. See you soon. I'm sorry, what?